So welcome everyone. Again, we are covering, get my slides around here to our intro. We are covering the AOV analysis and reporting options today. We're going to kind of recap what we covered in our very first session of this statistics series, going over what the AOV is doing for us, that the ARM is running. And then we'll kind of go through kind of the most common questions that we get in our support box from the statistical side, and show some options, some best practices, and tricks related all to that reporting in ARM, specifically the AOV means table report. So first up is to, again, we'll just recap. I won't quite cover this in as much detail, since that was something we went through a few sessions ago in our introduction, but these are the slides that we kind of talked about. And so to recap really what the analysis of variance is, that's the analysis that we're running within ARM when we want to look at our results of our assessments. And really, the goal is that we're looking at the variability in your observations. And so we're breaking down that variance into different causes, whether it's the controlled from your treatments and blocking, and then you have that experimental error that is uncontrolled. And so we're really comparing the variance within treatments versus the variance between treatments is our goal there, and is what we're doing. We walked through an example. I won't go through each individual calculation here, but we walked through an example and the different components we get in this is known as an AOV table. We've got a lot of calculations. Each row in this table is one of those sources of variability, and so we have a lot of calculations that we are using and going through in that AOV analysis. But the end result that we really care about is that the p-value at the end, and that is a probability. Specifically here in our case, looking at the probability that the variability that we're looking at, whether, here we had the between treatments, whether that variability between treatments occurred by chance is what we're looking at. And so having a low p-value gives us confidence that real differences exist. So that really was the really quick on the ANOVA. Once we do that ANOVA, we have kind of a general idea of a confidence for us if there is significant differences in those treatments that we were studying. That only takes us so far, about half of the way there, to know if there are differences. Then the next step is a mean comparison test, because we want to know specifically which treatments, which of these differences that we see in our assessment, which of those are significant. And so we run a mean comparison test after that AOV is done, in order to determine which of these differences are real and significant to us. We have a variety of options in ARM. These four are kind of the most common: the LSD, Duncan's, SNK, and Tukey's are the most common ones. We had discussed the differences between them and kind of how to choose which one to run. There's really no hard and fast rule, of course, as is a common theme in statistics, but we really were looking at the type 1 versus type 2 error. Are you more concerned about having a false positive, or really want to avoid false negatives? So it might depend on what phase your research is, might depend on what type of research you have, and thinking about your penalty of failure, I think is a big factor in how, which test to choose, and maybe also your significance level as well. Although the significance level really should be kind of planned out at the beginning when you're planning that protocol. You want to set that. And we had some extra details in a handout that we didn't cover before, but gives you a little more literature to read. Then finally, the kind of the end result of that mean comparison test that we care about is the letters. Kind of the typical way to display the results, and really wanting to show which differences are significant and which aren't. So anything that has the same letter, for example, 4 and 5, both have the letter A. So our analysis tells us that the difference between these two treatments is not significant. We don't see any indication that those are different enough. However, treatment 3 and treatment 4 has no letter in common, and so that would tell us that those two treatments are significantly different. So now how to read those letters. And we covered the assumptions of ANOVA last time around in the data review. So that's just kind of that quick overview of the analysis. What is ARM doing when we go to generate our report? And we're doing this, of course, with each assessment that we have in a trial. So with that, I'll switch over to ARM. And I have an example trial here that just has some data columns for us to utilize. Some of them are a little rigged, if you will, to demonstrate some of the kind of common questions and things that we see in support, and hopefully can be kind of illustrative for everyone here. But to give a nice general overview, if you're not familiar with the AOV report, we can use the print reports option, either on your toolbar here or file print reports. And specifically, we're looking at, in your list of available reports, we have a section of summary reports, and we're typically using the AOV means table is the main focus for us. You can see we have a few other options. If you are in a multi-factor design, we have a factorial AOV table. There's a repeated measures analysis, dose response analysis. The assessment data summary just gives you it prints out all of the individual data values and gives you just a simple treatment mean. So those are some other examples. We also have a spatial report that's just the AOV means table, but runs some spatial analysis with it. But the big hitter, the one that's most commonly used, definitely is the AOV means table report. We've got a lot of different options. I think just to start out with, I am going to preview this report and just give a quick summary of what we get when we create this report. So I'm going to press next. It's going to do some analysis. And if I preview. All right, so here in our report, and I will zoom in a little bit, so hopefully it's a little more easy to see. What we have in this report is the assessment columns, those ratings that we recorded. We have a header section, so we can have all the description of what was performed and what we recorded as part of that assessment for each of those assessment columns. Then we have our list of treatments. And so for each treatment in our study, we calculate a treatment mean for each of those assessments. And then we have statistics. You can see some of the mean comparison letters that we talked about a moment ago visible. And down below, we have a variety of statistics, which some of them you would recognize from last session when we were doing the data review. And then we have replicate and treatment p-values, just like we were talking about in the AOV table. Kind of a short summary there. So that continues onto a second page, however many pages we would need. I only have 9 assessments, so it's fairly short, but You can imagine the more assessments you do, this report can get a little long, but that's really the basis of your AOV report, and getting that analysis to see the results here for all of the assessments that we care about. So looking a little closer at this report, as I said, we kind of have some common problems planted here for us to find. And the first one comes from column 1. It's definitely kind of far and away the number one question we get is, where are my letters? And there's a couple of varieties of answers depending on the particular situation, but far and away that's the most common one. So here in this first column, the where are my letters question is because I don't see any letters at all. I've got this dash symbol, almost looks like we forgot how to record a negative value or something like that. So I'm very confused that I don't see the statistics that I wanted. How am I supposed to know if there's any significance here in this column? I don't have any letters. So the answer to that, if I close and return back, I'll go previous here. The answer to why we see those dash marks instead of the letters would be down here in our report options. We have a option, a symbol indicating no significant difference between treatment means. So when ARM has a column where there is no significance, there's a box here. You can specify what should be put on the report. And the default is this dash to show that there's, kind of a none in a sense. You can customize this, so you can remove that dash and put in whatever you might prefer. I've seen NS for no significance, and whether it's capital or lowercase, or maybe several dashes would suit you. Whatever nomenclature you would want to have shown on the report is fair game. I think we have 3 characters here, so you can have up to 3 characters that would fit on the report for when that happens. So NS is common. The other common one that people would recognize would just be to have an A. And if I just report preview here, you can see then that what you get is an A in all of the rows, which would tell you the same thing, that there is no significance. So probably just kind of a matter of preference on how you prefer to display it. All A's kind of blends in with the rest of the columns. Whether that's good or bad would be up to you. Something like a capital NS might stand out more, for better or for worse. So I think it really there is no right or wrong answer in this case. It would just be the way you prefer to have that shown. Whether it should stand out or you kind of want it to blend in with the rest of the columns, that choice is entirely up to you. And there's a question here that the LSD was used as the post-hoc test in the sample analysis. So right at the moment, I have if I go down, you can see that we do have a set of footnotes. And this is really nice here too. If you're looking at a report and you don't have the options, this is a nice way to get an idea of what was chosen when we ran the analysis. And the first one here tells us our alpha level at 5%, and then the mean comparison test we ran. So in this case, it's the student Newman-Kuehls that we're running for this particular report. And so the analysis, our results of what significance we see is based on the SNK. We do have the LSD value here on the report. And that's just kind of a common practice to have. We talked in that first session a little bit about the LSD mean comparison test. And it has a really simple test statistic. You just get one value for the whole entire column. In this case, it's 1.46. And it can be handy if you're going to make just like one particular comparison. So let's say going into this study, of course, we're interested in how all the treatments did, but maybe I'm particularly interested in how TUB did at the 2 rates. So that's really my focus, is just 2 versus 3. And so you could use this LSD value just kind of as a spot check. Essentially, you wouldn't want to do it for every single comparison. We talked about how that really gives you a really high chance of a type 1 error, of a false positive, as you do a lot of these comparisons with the LSD. But if you're using it just to make 1 or 2 comparisons, that's what it's really great for. And so that's why it ends up being on a report. So that 1.46, we could use that to compare 2 and 3, or to decide, did we see significance between just those 2? So that's kind of the reason for the popularity of the LSD being on the report is there regardless of what mean comparison test that you have. Kind of gives you an option to have your own mean comparison, if you will, when you have that focus. And another good question that we'll cycle around to. Looking at those LSDs, column 4 has something different, something special going on. And we'll get to that here towards the end of the session. Another example of a very common question that people have. So good eye there. We'll be sure to cover that a little bit later. All right, so the first question of where are my letters, came down to how they were displayed. And so here we changed it from a little dash to the A, or whatever else we'd like to show. So that's a common answer to that question, but it's not the only one. Like, we can still have people ask, where are my letters, in regards to the fact that they expect to see significant difference when they aren't. This case, obviously, all of the values are pretty close together, so I don't think you would particularly just look at this column and say, I would assume that my treatment 2 would be different than treatment 5, because they are still fairly close to each other. But that's kind of a common one, is just with my eyeballs, I believe there's differences, and yet on my report there aren't. And so how come the statistics is kind of telling me something different than what I thought there would be? Or if we were running the LSD test, maybe we even ran doing ourselves using the LSD value to compare values. It says, well, this should be different. How come it's not? We go back to our report options. We have an option right above the last one that we just talked about. This one is only when significant AOV treatment P of F. So this one kind of goes back to the workflow, our steps that ARM does in the analysis, where we are running the AOV analysis of variance, and then the next step is to run a mean comparison test. Well, if that AOV, remember we got a p-value for that, and that was a general, are there any differences in any of these treatments? And we would get a significance level of whether we have confidence that there is some differences or not. Well, if you get to that point and your p-value is not significant, then the ANOVA is kind of saying, I can't really find any differences. I don't think there's any differences here. So the theory is, well, if ANOVA doesn't think there's any differences, what would be the point of running a mean comparison test then? Because we already think there's no differences, then what would be the purpose of running a mean comparison test to see what differences there are? Well, we don't even think there is any in the first place. So when this option is on, then that's really what's happening. So if we look at that report again, really what matters more initially would be this treatment probability of F. If that's not significant, and in this case it's a 0.6, so not anywhere close to significant, then we see no purpose in running a mean comparison test at all. Therefore, even though we had our dashes or our A's up here, there was no mean comparison test run at all. We are just going to show there's no significance. Why look any closer when the ANOVA is telling us there isn't any? However, of course, this is an option, so you could turn that off, and then the mean comparison test will actually be run. So, there may or may not be any difference, in the results. In our case, there, excuse me, there really isn't in this case because they're so close. But that's really the logic behind that option, is to say, well, we shouldn't even run that. And so that's what's known as a protected mean comparison test. I think the statistical theory behind that, if I'm not mistaken, it's really, it's designed and important if you're running the LSD. As we mentioned, LSD is really liberal. It has a high chance of giving you that type 1 error if you're doing a lot of comparisons. And so that's really where this option comes into play. I think that's really the main purpose for having that, is if you're running the LSD, it might be wise to run that protected test. But as I understand, if you're using some of these more conservative tests, then maybe this is not as important. In a sense, and kind of what we have here in our report anyway, is that, well, it doesn't matter whether that option is on or not, because our mean comparison test will take care of that concern we might have for a type 1 error. We feel pretty good that we're not going to declare a false positive because we have a pretty reasonable mean comparison test. So we're not too worried about what happened in the ANOVA. So kind of pros and cons of doing that, but that's a common one that it just makes no sense why I wouldn't see significance. Well, that might be the case. There is that the ANOVA didn't find significance, and so ARM isn't even running the test. All right. So those are kind of the two big ones, I guess I would say. Just if I counted up all the different report questions we get, those two would definitely be kind of far and away the leaders of that statistic, if you will, of how often people ask them. Got a few more examples though that we can kind of go through here. The next one, looking at column 5 this time, over here on the right. And the question can be, for some reason, just one of my treatments, or maybe there's more than one, but one of them doesn't have a letter. The rest of them all do, and we have reasonable separation, but for some reason I don't have anything for my, in this case it's the untreated check treatment. It's empty. And certainly it would look like we would have significance for sure there. So if you don't see a separation letter for a particular treatment, you would want to look at the ARM action codes row for that column. And here we have ET1. So that action codes field is a place where we can give instructions to ARM on what should be done in the analysis. So I'm going to close this and just look at column 5 here. So we have that ET1, and that is excluding a particular treatment. So you can see that we are really dropping out that entire treatment 1 from this assessment when we're performing the analysis. But we do still report the treatment mean. So, we care about what that value was to at least some extent, but we don't want it in the statistics. We don't want to analyze it. So that is the ETN, where N obviously changes depending on which treatment. So this was treatment 1 that got excluded. You can do something similar for replicates. So if something went wrong in a particular replicate, you can put in an ER and then ER2 if replicate 2 should be thrown out, and you can do that then per for a specific assessment. Along that same vein, oops, I lost my mouse here. There is also an EC. So just looking at some of these other action codes that you may encounter, the EC is going to throw out the untreated check. So in our case, ET1 and EC is the same. It's going to give us the same results. I think the EC would be a little more clear as to the reasoning maybe behind why we're tossing out treatment 1. It also has the benefit that it could be any treatment, or if there's a change in treatment numbers, or if this was part of a standard assessment we wanted to save, then it doesn't matter if the treatment list gets moved around. ARM will look up in the settings. So if you view your trial settings, you can tell ARM in the treatment section what treatment number is your untreated. In some cases, maybe you have multiple. Maybe there's 2 different checks in your list. So you wanted more checks across the field or something. You can have multiple, and that EC then will make sure to drop out ones marked as the check. And in this case, this assessment, sometimes it totally depends on your assessment, but it was very obvious here that we had a lot of, is this disease here, I think? Let me check the part rated is, yep, or discolored leaf. So obviously the untreated was far more affected than our treatments. And so it may make sense to leave out the check. Number one, maybe that's not part of what we care about at all. Of course, our products are better than the check. They're better than doing nothing. I'm more interested in the difference between our treatments. That can be helpful sometimes to toss out that check and basically zero in on the treatments. So just to recap, that's the ARM action code. You can provide instructions to throw out certain pieces, certain parts of the data just in the analysis wise. So you still have them all recorded. We can still show the treatment mean, but it's going to act as if these were all missing data points as far as the analysis goes. Like they're not even there, essentially. Or if I had marked those as damaged. Let me put those back now. Not that we're too worried about that, but they really just are not included at all in the analysis. So that was this hole here where we didn't have a letter. All right, last possibility in this realm of where are my letters, and we kind of touched on it a little bit with this column 1 again, where we're just not getting significance. And so sometimes it can be a little frustrating that the statistics are coming out and not showing us those results, but we can kind of dive into a little deeper look at the statistics behind there as to why we're not getting significance. If you open the descriptive statistics section, I'm going to turn off some of these right now just because it's getting kind of a long section there. on the report, but we have a post-hoc power analysis that can be turned on in the report. And this will actually give us a couple of pieces of information. Actually, I'm going to make this full screen so we can look at the numbers a little better. So we turn on the post-hoc power analysis, and we kind of care mostly just about column 1 at the moment to understand a little better why we didn't get significance. And so when we turn on the post-hoc, there's a couple of pieces of information that come with. I'll start here at the bottom. We have a largest mean difference and a percent mean diff. So this is looking at our treatment means and finding which pair has the largest difference. So I think earlier we kind of had eyeballed that treatment 2 is the smallest and treatment 5 is the largest. So that is our biggest difference, and there's a 0.93 difference in there. What's our unit? Percent. So that's the biggest difference in our assessment here is 0.93%, and that ends up being 7% essentially of a difference compared to the grand mean, I believe. So that's what we saw actually, if you will. That was the actual results here. Pretty small difference that we're trying to detect. On the LSD, then up here, we have an additional value, a percent mean difference, and that's comparing the LSD, which was our 1.46 that was calculated. How big of a percent difference is that? Really, that LSD kind of represents the best chance we have at finding significance. And so that's sitting at 13%. So we can only detect, we would only have a significant difference if there was a larger difference between treatments, larger than 1.46. And in this case, we only had 0.93 was the very largest. So that would explain why there's no differences. And so then looking at the statistics behind that and kind of the power analysis of what what's going on behind there, we end up with a minimum replicates calculation that tells us that if we were to do the same assessment and we ended up with the same type of results with 0.95 standard deviation, that same kind of amount of variance, it would have taken 17 replicates for us to have significant difference. Whereas in this study, I think we only have 4, maybe 5. So that just gives an idea of kind of where the chips fell, essentially. Kind of after the fact, of course, it's far too late for us to add more replicates. The trial's all done, but it can give you a sense, number one, of how things shook out, and maybe give an idea of what should happen next year. That, well, we need more replicates, whether it's more replicates at this one trial site, or maybe that's just a sign we need to combine this trial with some other locations. And then maybe we will see some significance because we'll have more statistical power to be able to separate and see differences. And just real quick, to compare that with column 2, where we did have very clear significant difference, that post-hoc tells us we only needed 2 replicates. So we did a really, really great job, super easy. We had no problem. You could have even gotten away with fewer replicates and still saw significance. So that's the post-hoc power analysis, just to kind of give a sense of what happened, what would you maybe need in order to see significance. And in this case, it's pretty solid no of nope, it was not going to give us significant difference based on the results, unless we pull in some more trials, perhaps. Let me go back. That was just on the descriptive statistics. And you probably don't really have to do that for every column that you're looking at, but at least the ones you care about the most. What was the objective of this study? We had these three assessments that matter the most. Is probably where you'd want to focus your time on that post hoc. Just running out and doing a quick stand count or something, probably we're not too worried about seeing significance there. So of course, a lot of this, it just depends on what you want to focus on, whether it's worth all that looking at an additional analysis. All right. So that was kind of all fitting that theme for us of where are my letters. Have a few other ones, kind of all across the board here of different things that people ask and run into. One of them would be actually the treatment mean itself. So sometimes people would look at, and let's find this untreated check. So column 4, I think, would be a scenario where we might have that concern. Column 4. Yeah, so here we have column 4. I've sorted by treatment, so I have all my treatment ones together, and we can see with a quick mental math that we would have 2.5 would be the average of those values we would expect. So we have a total of 10 divided by 4, 2.5 would be the mean that we would expect to see. However, when we preview this, we'll notice that that's not quite what we saw. We got 2.31. So the question, what is this 2.31? Where did you come up with this? Because using my head, I have a different value. Why is that not being reported here? So there's a couple of possibilities. The first one could be a missing data point. So if we did have a missing data point, then the analysis needs to make an adjustment. And just depending on some of your analysis choices, there's a few different methods for adjusting. I'll try to keep this brief, but it really comes down to the analysis method that you've chosen. There's the traditional AOV, generally not recommended, but if you are running that, then the traditional AOV requires a missing data estimate. So we have to basically put in a value in that point, whether it's been marked as damaged and we threw it out, or if it was missing and we never had it in the first place. So on the general summary tab, there's a missing data estimate. So you can choose whether we use the Yates correction or just take the average of all of the other existing treatment data from that treatment and have that be your missing data point. So if you had average, of course, then you would get the average you were always expecting. That'll end up being fine. But Yates has a little more involved, so you don't end up with that same average. There's a little more going on there because it's trying to account for variations and other replicates. If you're doing the least square estimation, which is generally recommended, it usually does a better job, especially with missing data points being present, then there's an adjusted mean. So again, very same situation. We're missing a point. We really wish we had it. We need to make some changes. We can't just pretend that isn't there. We need to make some adjustments, but instead of specifically putting a value in, we can just adjust our mean using particular calculations. And so that you may see on the report with that asterisk right next to the column names. And then down below, you'll see that is adjusted means could be used. Typically, if you don't have any missing data, it'll be the same. The other scenario, so I guess we saw a missing data point earlier, but in this case, it's not really about missing data. The other scenario where you don't see the value you were maybe expecting here, that 2.5, is because of the presence of a data transformation. So here in this column, we have the log transformation being applied. And we try to denote that here in column 4, that we've got the D transformed AL is what we are displaying here. So basically, again, that action code is instructions for the analysis. It performs a logarithm transform on all of the raw data, and then we do the analysis on that transform data. Well, if we were to display the log of 2.5, that's not going to mean very much to us. I have no idea in my mind what the logarithm of a percent means in the real world. That it's not going to do me any good to have that weird value there on the report. So what we do is perform the inverse transformation to bring those values, those means, back to something that makes sense to us, that we can imagine. So those are D-transformed means. This 2.31 is a D-transformed mean. Again, you can see that with this D symbol, that the means are reported in a D-transformed data units. So what we basically have is a weighted mean because we did that log transformation. So we don't end up right back at that 2.5. But that 2.31, kind of the best representation of what the analysis, all this decision making here that we came out with, matches that 2.31. We do, within the last year or so, we added an option, because sometimes it's not maybe desired, or I guess I should say, sometimes it's desired to display that raw value. So that 2.5 maybe is what I actually want to show. So it's, sometimes that's really, I want to see what actually was there, please. And then whatever the statistics was, great, show me the result. But I'm not too worried about that weighted mean or any of that. And so we added here in the main report options section, we added an option to show the arithmetic mean. And that's really that raw mean, that 2.5 that we've been talking about is really what we want. And we can have that show up beside the mean or underneath the mean. I think I'm going to use underneath the mean here to show. So for column 4 here again, we can see that 2.31 is that weighted mean we've been using with the statistics, but now we can also display that 2.5 arithmetic mean. So that you have that option to see. And each of these you can see there's just a slight difference. And each one of them is treated fairly in the realm of statistics, but yeah, sometimes it's kind of desired to have that regular mean there. Kind of probably comes down to your audience, I think. If you're generating this report for another researcher for your group, I think researchers kind of understand that transformation and maybe why those values are a little different because we're doing some statistics, but other groups might be very confused, and you don't need to have all that extra explanation for whoever you're sending it to. Maybe it's much simpler to give them the raw values. You could display both of them, or if you wanted to, you could turn off the primary mean in that scenario. So we keep it separate so that way you can't be confused if you were to do an LSD value or something, to know that you can't quite compare those with the LSD because they're not the same. But that's one option, again, just depending on, I think mostly the audience maybe of your report, perhaps, would be the number one consideration of how you want to display that. Bringing in the arithmetic mean. It's a little noisy. It might be easier beside the mean. It's kind of nice to just play around with some of the options and preview to see that seems to fit a little bit nicer, perhaps. But we did keep it separate to show statistics are all over here, and then the arithmetic mean has nothing to do with statistics. Hopefully that helps people to kind of understand the difference. And while we're here, since we did have the question earlier, in this column we have that LSD is a range of values. It's not just one. And that is because of the presence of this AL, that log transformation. So again, it kind of comes down to the fact that behind the scenes, we're transforming the data. So the LSD that you would use, it would be different depending on which comparison you're making. So if you can imagine, we're doing the log of each of these, values. You kind of have behind the scenes laid out for us to use in the statistics. So then when we run the mean comparison, we're looking at those values. So you would get that LSD value that could be used on those log numbers. Well, we don't have those log numbers anywhere on this report. We've de-transformed them. So we have to de-transform that LSD value as well. But if you're comparing like the smallest two, then you would use that 5.7. So if I was comparing 1 and 5, you would use the 5.7. If you're comparing the biggest two, the farthest apart two, you would have the larger value, the LSD value. And every comparison within then would be somewhere on this line. So it's a little bit clunky to use, but statistically correct, if you will. That is the reason for the range, as you can't just use just one value because those comparisons are actually done on a different data set. It's the transform data set. If you don't want that de-transform, we actually have an option to turn that off. So if you turn this de-transform off, this was under the general summary, then when we preview, you'll actually get here the AL values themselves. So now 0.52, 1.35, those are the means of the transformed data. And so that LSD is just a single point now because we can use that 0.35 to compare these. But again, now that 0.52 is the log of a percent. So you kind of have to decide what makes the most sense and what's easier to read. But that's kind of the theory behind those options. There's a question here before we move on. How do you calculate the average of two data columns in ARM and then run ANOVA on it? So you have two different observations, two different spots of a plot, or maybe it's a multiple harvest. So, strawberries, you're harvesting constantly, and then you kind of like to see the grand total across that whole time, and you took 12 assessments. I like to calculate a grand total. That's actually a great preview for our next webinar in November with the transform dialog. So under tools and transform, you can create your own calculation. We have some calculations here, but there's a user formula, just kind of like Excel. So you could do column 1 plus column 2 and put it into column 10, and it'll create a new assessment column with that some calculated values, which you could then run an ANOVA on. Good question. We'll dive into that, like I said, a lot with that data calculations webinar coming up. All right. So that was a lot of questions here that we covered. They're frequently asked questions, I guess. I'm checking here. We did most of the common questions. A couple of reporting features, I think that kind of fit in the same vein, to maximize your report and be able to customize and tweak it the way you'd want. So far, when we generate this report, ARM has given us all of the columns in the trial, but you can select specific ones if you want to hide some of them, or you can change the order of the columns. In the General Summary tab, there's an option for the assessment data columns. If you have it set to automatic, which is by default, it's going to bring all of the columns that have data. But if you turn on select, then when we press next to generate the report, ARM will ask us, which columns do you want? And so you can change the order. The order that you choose them will be the order on the report. And you can click on, or you can type in this box down below here. Maybe I'll just make this unusual order here. So now we have 4, 2, 3, 1, 6. So the order that we selected them in is the order we get on the report. And that also allows you to drop some of them out. Kind of a similar option, again, in the general summary. You can also do that for the assessment data header rows. So this top portion here is what we call the header, that you're describing the assessment, and you can customize that as well. Automatic will take anything that has information filled in it and drop out ones that would end up being completely blank. But select would allow you to choose specific ones and maybe leave out some of them. And you also changes the order of them. And that's a common one. I think sometimes people ask, how can I save space? My report's really, really big. I've got 110 assessment columns, and they're, each column's taking up 2 pages, and I kind of have a mess, and it's ending up very, very large. And this is one of the first things I recommend is trimming down those assessment data header rows. Because you can see here when we had it automatic, there's just so much room here. You have 4 rows for the pests and like 4 for the crop, and some of these maybe don't matter as much in the final summary. Things like that, you can really trim that down and save some space, so that way your statistics don't get cut off and end up being bumped to another page, which is typically what kind of the big trigger where you have problems with that. Another case where you can end up with a lot of excess space would be your treatments. So here I only have the rate and the application code, but if you have a lot of treatment fields, then they all get put here and kind of pushes everything to the right. So here I've got 5 columns that fit on this page, but if I had a lot more of these pushed over, maybe I can only fit 3 columns. So that's another way to save some space, is to change which columns are included on the report. And that's actually in your global settings. So if I go to my global, I take that back. It probably depends here first to look at your treatment fields to print from options. And this is usually on to say for each individual report, I want to use, I want to have my own selection of which columns to include. That's usually on. So as long as that's on, then you would go into the, let's see, is it here? Let's go to more options. I know it's on one of these sections. Here we go. So in the more options, there's a fields to print tab. And so I could turn off. So here I've got treatment number, treatment name. I could turn off these other components to really shrink that down. So here now I have just those 2, and now I can fit, I'll be able to fit more, maybe 1 more column here. But definitely makes a big difference if we went the other direction. and had a bunch of them. I guess I won't waste the time to show that, but yeah, if you had a bunch of columns, that'll kind of take away some space. One last one, because we kind of showed it with the ET, where we were excluding treatments and excluding replicates in the action codes field. That is kind of a per column. So one specific assessment, I can throw out a treatment, throw out a replicate. But you could also do that across all of the columns in the report. So in the global report settings, there's an option for the treatments. Usually it's print all, but you could make it print selected. And the same thing with replicates on the general summary. I'm going to set my columns back to automatic. At the very bottom, there's a print selected replicates. So now when we generate a report, ARM is going to ask which treatment should we include. So if for some reason, across all the assessments, we don't want to include the check for whatever reason, we can do that. So 2 through 5, now all of the data for the check is going to be completely dropped out of the analysis. It'll still be in your trial, so you can always come back and run a report with it being included. And then same thing here with the replicates. So we've got sorted by replicate 1, 2, 3, 4. I could throw out replicate 3. And again, this is really just making it invisible to the analysis, but not actually deleting anything from the trial itself. So here, 2, 3, 4, 5, you can see there is no column number 1, and all of our values are different. You know that. I didn't make any specific note of the values, but they're all different because we've tossed out that replicate 3 as well. All right. Well, I think we covered quite a lot. I've talked myself right to the end of our hour. I do have a couple minutes if anyone had questions they were holding to the end. But if not, I want to thank everyone for joining us in this session and all of our previous ones this month. It's always great to see the interest. The statistics is always the most populated one that we get each year. Hopefully we learned something, picked up some tricks. If you do have any troubles, especially kind of on this topic here with your own report, with your own trial, of course, things always just look a little different. Feel free to shoot us an email if you're having troubles or questions with what you're seeing in your report. It takes, I'm in this daily. I'm always looking at those options, whereas you maybe haven't picked up a report since last fall. So we never have any troubles answering it quick. Here's that option you're looking for. So yeah, thanks everyone for joining, and hopefully maybe we'll see you at a future session as well.